Everyone, welcome to week 12. We are going to continue our study of sequence and series. We introduced sequence as a set of numbers which follow a certain pattern. When we add them, it's called a series. Today, we look at a special kind of series called alternating series, which means the terms alternate between being positive and negative. For example, 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth and so on. In general, whenever you see a negative 1 to the power n or to the power n minus 1, that is an indication. Sorry, it's going to load in a bit. That's an indication that you're working with an alternating series. And that is because when you take powers of negative 1, it alternates between being positive and negative. So we have a special test for this kind of series called the alternating series test. So if you have b1 minus b2 plus b3 minus b4 plus b5, and it satisfies this condition, essentially what this condition is saying is that it is decreasing, and the limit as n goes to infinity of the bnth term is 0, then the series is convergent. If either, this is the second one is the most important. If this fails, it is not going to be convergent, which sort of makes sense with our earlier discussion about the limit of the sequence. If it's not 0, that means you are still continuously adding something that is non-zero, so it could get to infinity. Let's look at this example here. First of all, we write the terms of the sequence. So it's 1 minus 1 half plus 1 third minus 1 fourth. So it's basically the harmonic series, but alternating. 1 over n plus 1 is definitely less than 1 over n, so it is decreasing. That's because for a fraction, if the denominator is larger, with the numerator being same, it's a smaller number. And the limit as n goes to infinity of 1 over n is 0. Both of these together tells us that the series is convergent. Let's look at a couple more examples. Analyze this particular scenario here. So here, the first thing that we can immediately notice is that the limit is not 0, which means that it diverges. Right? And that's because these are kind of like polynomials, or with the ratio, with the coefficient, the ratio of the coefficient becomes the limit. Remember, the trick is that you divide by n everywhere. You end up with 3 over 4 minus 1 over n. This goes to 0, and that's why you're left with 3/4. Now, what about this particular sequence? Now, there's a couple of strategies here. First of all, you want to determine if it is decreasing or not. So we can take the help of calculus by constructing the function and looking at where it is decreasing or increasing. Right, so if I take the derivative of this function, I'm going to be having 2x x cubed plus 1 minus x squared 3x squared, which really becomes 2x x cubed plus 1 minus 3x to the 4 over x cubed plus 1 squared. It's factoring out an x. I get 2x cubed plus 2 minus 3x cubed over x cubed plus 1 squared. So f prime x is going to be x 2 minus x cubed over x cubed plus 1 squared. Now this quantity is always positive, so whether or not it's increasing or decreasing depends on the roots of this equation, which is 0, and you have a cube root of 2. Right? Now if you are over cube root of 2, this is going to be negative, positive, negative. So over here it is decreasing. The cube root of 2 is a number just over 1. So we are fine in the sense that we can say that this is decreasing. Now, if it is decreasing, we can find the limit, and we use the same strategy as before. This is, we divide by n squared. So we get 1 n plus 1 over n squared. This goes to 0, and all of this goes to 0. So the limit is 0, which makes it convergent. So sometimes you may have to transform it into a calculus problem. That's always true whenever you have to show something is increasing or decreasing. Okay, next video we talk about